Hi there, welcome back to the Good Tutor Premier Prep SAT course. And in this video, we're going to look at the problem solving and data analysis subsection of the SAT math section. And specifically, we're going to get an introduction to the conversion between units. So to start with a bit of an introduction here, we want to say that conversion between units is going to be most common in word problems, and specifically ones in which more than one or multiple conversions must be made. So we're really not going to need to use the strategy we're going to learn in this video on problems that only have one conversion. If we need to go from, let's say, inches to feet, let's say, or feet to miles, and that's going to be a little bit more straightforward and just multiplying by that conversion factor. This one, in this case, when we have multiple conversions to be made, we're going to use a series of proportions like we learned about in our last video, and we're going to set them up so that equivalent units will cancel as we go along. And what this means is if we look at that sort of parent function there, we have a over 1, which is where we start, whatever unit we start in, is equal to b over a, is equal to c over b, and then so on and so forth if we needed more conversions to be made within one problem. The idea, though, the important point to take from this equation that we have set up here, this series of proportions, is that whatever variable or whatever unit, of course, was on top to start, in the next proportion, in the next ratio, it's in the denominator. See, so a goes from the numerator in this one to the denominator of that one, meaning it would cancel as we made our final calculations. B starts in the numerator, ends in the denominator in the next one. Those would cancel, and we would be left with whatever number was left of that C unit, of that last unit in this case, right? And then, of course, we could keep it going, right? And we could have D over C if we needed to keep going and make another conversion, right? Then the C's would cancel, and we would be with that unit, the new unit, right? So that's the idea, is that our units, as we continue, will cancel so that we can end in whatever unit is desired. So let's go ahead and view an example of this. In a particular galaxy, the closest star to the planet Oasis is approximately 4.3 light years away. Another star, called Andros 1, is twice that distance from the planet Oasis. If 1 light year equals 63,000 astronomical units, or AU, and 1 AU equals 150 million kilometers, approximately how far is Andros 1 from the planet Oasis in trillions of kilometers? And that's our trillion there, a 1 followed by 12 zeros. All right, so let's see. What is our initial ratio, right? Our initial fraction? Well, it looks like we're given light years, 4.3 light years. So that's going to be our first proportion. So 4.3, put LY for light years, over 1, right? That's our a over 1, like we referenced here, right? A over 1. So if we have 4.3 light years over 1, then we'll have to set it equal to, or essentially multiply by. And that's really what I want you to do more than anything, is actually multiply by each new ratio so that we can get a final ratio. Because yes, while the parent form we showed, right, had them equal to each other, and that is true, that was just to show them as proportions, and that is true. But we're actually going to multiply them together to basically simplify all of those equivalent proportions into the unit that we want, into that final unit, right? So 4.3 light years over 1 is going to be multiplied by, now we want light years, we know we want light years on the bottom, right? And in the next one, it looks like that we are told 1 light year equals 63,000 AU. So 1 light year is 63,000 AU. All right, that same conversion, right? So it would be equal to, and again, we're multiplying so that we can get our answer in a simplified final unit. Next, we know we want AUs to be on the bottom. So now it's going to be something AUs. And in that next line, we're told that 1 AU equals 150 million kilometers. So 1 AU is 150 million, like that. And it looks like our final answer, because that's what we need to ask ourselves, right? What is the final unit? And the answer is kilometers. So this one should get us to kilometers, right? Because kilometers is the last one left in the numerator, right? Because light years will cancel, AU will cancel, and then we'll be left with those kilometers. So now we need to multiply this 4.3, 63,000, and 150 million. All right, and when we do that, and then we divide it by, the denominators, which is, of course, 1 times 1 times 1. And when we do, and you can pause the video if you'd like to figure that out, you should find 8.1 times 10 to the 13th. It'll probably give it to you in scientific notation like that. However, we're asked in trillions of kilometers, right? And obviously 8.1 times 10 to the 13th is not any of our answer choices. But we said that 1 trillion was 1 followed by 12 zeros. Well, this 13 would actually mean we have 13 zeros, right? So if we want to make that only 12, we'll have to move that decimal place 1 over, and you would have 81 times 10 to the 12th. And the 10 to the 12th in this case, right, represents trillion. So it'd be 81 trillion. So D is our correct answer. So it's 81 trillion kilometers away. And that's how we used our different conversion factors, right, between we got from 4.3 light years to 63,000 AU times that, and then times the 150 million kilometers that are in each AU, and we reached our final answer. All right, that's it for this video, and up next, we'll be working with percents.